time for a moments question, and there's this little bit at the bottom here, which is again something we want to check. Okay, so this question, we are going to work out moments in both of the ways that we looked at earlier. So if we look at the weight force here, you can see that we've got right angles there. So this D that we're looking for, we can see there's a right angle between it and the weight force. But the tension force there, this is where it acts here. And so there's no right angle between that and the distance to the point that we're interested in. So I'm going to draw that in as I did in the previous videos with the highlighter just to be consistent. So from where the force acts to the point we're interested in, that is the displacement vector for this force. And so that is 0.75. So the tension, my displacement vector is 0.75 meters, and the angle between the force and the displacement is 50 degrees. Okay, and then there's my weight force. So the weight force we're going to have to calculate. We'll need to round to two significant figures at the end, but leaving it unrounded for now. So that's the weight force, and then it's the perpendicular distance, D, is the thing that we're looking for. So applying the principle of moments once again, the sum of the clockwise moments equals the sum of the anti-clockwise moments. The only force trying to turn the object clockwise about the support is the weight, and the only force trying to turn it anti-clockwise about the support is the tension. So here we have the weight times the perpendicular distance is equal to the tension times the displacement, size of the tension times size of the displacement times the sine of the angle between them. And then leaving you to do the algebra, that should give you now finally at the end rounding to two significant figures, D equals 0.25 meters. Congratulate yourself if you got that one right. And then explain why the force at the support cannot be vertically upwards. Okay, so the force at the support. This block, whatever it is resting on something here. So that means if it's pushing on the support's pushing back. So there's some kind of normal contact force going on there. Okay, and the question is, why can't it be vertical? So now we've finished thinking about moments, and now, as usual, at the end, we're thinking about forces again. And so on our object, we've got a weight force vertically downwards. We've got a tension force at an angle, and then we've got this other force, a normal contact force. Now, the object is in equilibrium, it's not accelerating, and that means that all the forces on it must add up to zero. Now, if you've got a downwards force and a diagonal to the left force, then that means we have to have, whatever this n is, it has to have a component to the right, because W and T can't be cancelling each other out fully. There has to be something to the right to cancel out the component of T that's to the left.